Welcome, and thank you all for joining us. Today's webinar is using the practice guide to improve mathematical problem solving in grades 4 through 8, hosted by the Regional Educational Lab for the Northeastern Islands region. Here's our agenda for today. We'll do some brief introductions, followed by an introduction to the What Works Clearinghouse Practice Guide, Improving Mathematical Problem Solving in Grades 4 through 8. We'll also hear from a teacher on her experiences in using practice guide recommendations, followed by a facilitated question and answer session, and a final wrap-up and evaluation. REL Northeastern Islands is one of 10 regional educational laboratories. Our region is the 6 New England states, New York, Puerto Rico, and the U.S. Virgin Islands. We work in partnership with educators and policymakers in our region to develop and use research that improves academic outcomes for students. We do this by conducting research studies, disseminating research findings to those we serve, strategically engaging with our partners to use those findings, and designing and delivering technical assistance focused on the use of data and research. The goals for today's webinar are to learn about the information in the practice guide and the quality of evidence that supports the recommended instructional practices. Explore how the practice guide supports professional development for mathematics teachers in grades 4 through 8, and identify and discuss ways that mathematics teachers in grades 4 through 8 can implement the practices in the guide. Presenting today will be Dr. Herb Turner, Dr. Pam Buffington, and Becca O'Coin. During the past 2 decades, Dr. Turner has contributed to innovative and cutting-edge initiatives designed to transform education research at the national, state, and district levels into an evidence-based, scientifically valid field. These initiatives include the Campbell Collaboration, the What Works Clearinghouse, the Regional Educational Laboratory Program, the Social Innovation Fund, and the Investing in Innovation Program. He currently serves as a WWC trainer and quality control reviewer for the WWC Statistics website and training, funded by the Department of Education's Institute of Education Sciences. Dr. Buffington is a national expert in rural education and mathematics education. She guides policymakers, education leaders, and teachers in improving K-12 student outcomes. She brings extensive experience in rural education, place-based learning, research, and distance learning networks to her leadership of Education Development Center's Rural and Ready STEM initiative. Dr. Buffington specializes in expanding access to high-quality STEM education, closing opportunity gaps in mathematics education, and bridging research and practice. We'll also be hearing from Becca O'Coin, who is a math teacher in Framingham, Massachusetts. And with that, I'd like to turn it over to Herb, who will be facilitating today's webinar.
Okay, thank you, Shauna. So we'd like to begin today and specifically focusing on the Improving Mathematical Problem Solving in Grades 4 through 8, a practice guide. And to begin, I'd like to pose the first question, which is, what is a practice guide? Now, the WWC defines a practice guide as a publication that presents recommendations for educators to address challenges in their classroom and schools that are based on the following 3 things: reviews of research, experiences of practitioners, and the expert opinion of a panel of nationally recognized experts. In addition to the practice guide on mathematic problem solving that we will discuss today, there are 5 other WWC practice guides that address mathematics instruction, 4 that address mathematics instruction directly, and 1 that addresses mathematics instruction indirectly. The links to access these guides will be shown at the end of the webinar. All WWC practice guides have evidence-based recommendations that can be acted upon. And the key emphasis here is evidence-based recommendations. The example of recommendations in this slide are from the Mathematical Problem-Solving Guide for grades 4 through 8. The 3 recommendations are as follows. Assist students in monitoring and reflecting on the problem-solving process. Teach students how to use visual representation, and expose students to multiple problem-solving strategies. Now, these are 3 of the 5 recommendations that are in the guide itself. However, these 3 recommendations that we see on the slide will be discussed in more depth later on in the webinar by Pam and Becca. So why is the practice guide important? Well, there are 3 primary reasons why the practice guide is important. Number 1 has to do with the breadth. 3,700 citations were yielded from the initial search for literature related to problem-solving instructions, and this literature search was conducted over the past 20 years. Then based on that search, 38 studies met the causal validity standards of the WWC and were related to the panel's 5 recommendations. Finally, and importantly, using these 38 studies, the panel determined whether there was strong, moderate, or minimal evidence for each recommendation. So in summary, the Improving Mathematical Problem Solving in Grades 4 through 8 Practice Guide is important because of the quality of the search of the literature for the evidence and how the expert panel used the results to determine the strength of the evidence in support of each of the 5 recommendations. Further, the literature review for the guide was restricted to mathematical problem-solving topics typically taught in grades 4 through 8, and is designed to be used by all teachers, including those in special education and those that teach English learners. Before moving to the next slide, I'd like you to notice in this current slide the time frame of the initial search, which spans 20 years, the number of citations identified for the initial search, which is 3,700, and the number of studies, 38, related to the expert panel's 5 recommendations that met the WWC standards for causal validity. This slide shows the 5 recommendations that will be the focus of the remaining webinar in terms of their use to provide professional development and coaching to teachers and guide math instruction to students. One thing I'd like you to notice about the recommendations is that there are varying levels of evidence for each recommendation that convey how confident the WWC Practice Guide panel is that the recommendation consistently improves student outcomes. So if we just briefly walk through the slide, you will notice that the first recommendation, prepare problems and use them in whole class instruction, has minimal evidence, which suggests there would be minimal level of confidence that this recommendation would improve student outcomes. But there is some level of confidence. Then notice the next 2 recommendations, assist students in monitoring and reflecting on the problem-solving process, and teach students how to use visual representation. The confidence there that these recommendations can improve student outcomes is high because the evidence in support of these recommendations are strong. And then finally, notice that for recommendation 4 and 5, recommendation 4, expose students to multiple problem-solving strategies and help students recognize and articulate mathematical concepts and notations. There, the confidence that these recommendations can improve the outcomes for students in grades 4 through 8 is moderate because the evidence in support of those recommendations are moderate. I'd also like to point out we had a question that was submitted prior to the webinar about the relationship between the levels of evidence that are shown here in the slide and the ESSA evidence tiers that are not shown here in the slide. It suffices to say that the basic correlation between the level of evidence and the ESSA evidence tiers is pretty straightforward in terms of, for recommendation 1 that has the minimal evidence, that would correspond to the ESSA tier 4. For recommendations 2 and 3 that have the strong evidence, that would correspond to the highest level of evidence in ESSA, which is tier 1. And for recommendations 4 and 5 that had the moderate level of evidence, that would correspond to ESSA evidence tier number 2. Before leaving this slide, I also like to make one final point. For a recommendation to receive a higher evidence rating, such as moderate or strong, studies supporting a recommendation must use high quality, rigorous design, such as a randomized controlled trial or quasi-experiment, must be well implemented, must represent a diverse range of students and contexts, and must meet WWC design standards. Furthermore, despite the varying levels of evidence for the recommendations in improving math problem solving for students in grades 4 through 8, the panel that developed these recommendations believes all 5 are important for promoting effective problem solving skills in students. So with that said, I'd like to turn the webinar over to my colleague Pam, who will introduce a practitioner perspective on using practice guide recommendations.
Thank you, Herb. So today I'm going to start by reinforcing something that Herb said earlier, and that is that I'm going to focus specifically on 3 of these recommendations in terms of recommendation 2, assisting students in monitoring and reflecting on the problem-solving process. Recommendation 3, teaching students how to use visual representations. And recommendation 4, which focuses on exposing students to multiple problem-solving strategies. I currently am a PI of an NSF-funded project titled Visual Access to Mathematics for Teachers of English Learners. In that particular project, we have integrated these recommendations from this practice guide, among others, and also have integrated other recommendations from other practice guides as well. I'm going to focus in on these, however, just to really dig into what the content of these recommendations are. So as Herb pointed out, in the practice guide itself, there are descriptions of the recommendations individually and across all 5 of those recommendations. In that context, they define what the terminology is that they're using. They have a set of definitions, illustrative examples, summary of evidence, and how to carry out that recommendation. So what's really helpful for practitioners and also for professional development providers and designers like myself is that there are real clear examples of what is meant by that particular recommendation. So what would this look like in practice? What we have done in our particular intervention was to integrate visual representation into a worked example. So you can see here the type of activity that we might engage teachers in our intervention. We had teachers look at, think about, and analyze the worked example, where we have integrated, as recommendation 3 acknowledges, the importance of using visual representations as students attack and solve problems. By having teachers engage in these worked examples, another area of recommendation, they make that problem solving explicit, as you can see here. Additionally, within the recommendations, you are able to review and consider the evidence that the panel looked at and considered, as well as roadblocks and possible solutions. This is really critical for math coaches, teachers in practice as well, to say, you know, how can I implement this particular recommendation, but also what might I run into, and then what is an approach that I might take. So an example here is roadblock 3.2. The class text does not use visual representations. So there's a recommendation that teachers ask colleagues and math coaches for visual representations, tasks that they can implement that have those integrated, or develop some of their own. So in the particular professional development that we developed, we created examples, and I'll show others here, that were explicit for math teachers who often, beyond using language access and production types of strategies, really have not considered how to translate some of these recommendations into practice. So examples really help in terms of implementing these recommendations. I'm going to use another example of what does this really look like in schools and classrooms. So here's an example of a math task. The problem is asking, if Gus ran 3 times as fast as Ike ran, Gus and Ike ran a combined distance of 48 miles. How could students engage in understanding the problem, creating visual representations? So I'm going to actually open this up to you as learners at this point, and think about the representations you see in front of you, which were generated by students. And if you were solving this, which of these do you think accurately represents the problem of Gus and Ike? Is it figure A, B, or C, or all of the visual representations, or none of the visual representations? You have on the right-hand side of your presentation screen a poll, so please take some time to take a look at the examples and respond in the poll. As I'm watching the responses come in, I'm noticing that 63% of you who have responded are responding that all 3 of these, A, B, and C, would be representations that could accurately represent the problem. Some of you have chosen figure A or C, and so any of these responses would be an appropriate response. And if we dig into those representations, there's great analysis to be done by teachers about how these all, in fact, do represent the problem here and help to move students to solutions. So I'm going to move on to the next slide. Thank you for playing along. Here is another slide that shows another task that includes a visual representation in it, as well as actually worked examples, providing a partial visual representation. This happens to be a double number line, and then you'll see here a solution. So one of the questions that came in from those of you who registered actually asked about how do we translate this to practice with the support of a mathematics coach. The mathematics coach was not available to be on the call today or on the webinar, but some of the things that she brought up, and these will be reinforced when Becca talks as well, is that providing examples of the visual representations to mathematics teachers, similar to the answer to that roadblock in the practice guide, having specific things related to the content of the grade level of teachers that you're working with is really helpful. Providing opportunities to review the examples in a professional learning community setting, whether it be online now or in person, being able to look through, talk about, and analyze the work of students, and also being able to model or co-teach examples similar to those in the practice guide have been extremely helpful. Now, Becca, I'm going to turn it over to you in just a moment, but do you want to add anything in terms of how do you actually translate this? What could a mathematics coach do to help support these type of recommendations?
Sure, Pam, thanks. The best thing that I have found to feel supported in trying to implement some of these recommendations is to just be provided with time. Being able to really wrestle with these problems and look at all of the different ways that they can be solved, look at student work with them, and then just practice over and over again, how am I going to do this lesson? And I think the modeling and the co-teaching is really, really important because we didn't learn this way when we were in school ourselves, and education programs to prepare us to be teachers often leave these types of things out. And so teachers just really need time to be able to analyze these representations and look at all of the different ways kids might try to solve it, and then talk about different talk moves you can make during the conversation to look at and link the different representations that may come up. I would love to continue on and share just some examples from my practice as a math teacher. So I've been teaching in middle school for 13 years, and just like anyone else, my first year I was just happy to be there and took the curriculum and did what I could, and it quickly became very apparent that the way I was teaching was the way that I learned, and it wasn't the best way to help all of my students to learn. And so I was able to have access to the Visual Access for Mathematics course that Pam had been talking about earlier, and it really opened my eyes to the best learning and the richest lessons that we have with students. They're not problem sets where students finish all of the questions and get the right answers. It's those moments where we're able to look at relationships between quantities and really talk about what it means. So there's an example on this slide just of a question where you're really talking about the relationship between those quantities of jelly beans. And what's pictured is a tape diagram, and I'm slightly embarrassed to say I had no idea what a tape diagram actually was before really getting into the VAM course. And when students see a tape diagram for the first time, they need to explicitly be taught how to use it. And so in this case, we've got Hector and his jelly beans, and there's different colors to represent the portions. And this is just one example of how kids would be able to mark up the tape diagram to show the problem, but it gives such a nice, clear way, just a visual of exactly what kind of quantities we're talking about here. Kids could quickly look and see, oh, Hector has the most. A 3-read strategy is also one that really helps the ELs in the class to break down the text and to be able to just really understand what's going on in the problem, being able to understand what are jelly beans and what does it mean to give them away. For some ELs, these are the text issues that we encounter with traditional curriculums. And so being able to read the problem 3 times, to have conversations about the words before we even start to represent it can be really helpful for our ELs. I also wanted to show an example of something that I ended up creating after being able to participate in the course, because the course really just made me reassess the way I taught ratios, proportions, and percents. In 7th grade, that's a pretty major unit, and I had been going from equivalent fractions and introducing them to proportions and then saying, that's it, we're done. But now I've completely revamped it to use tape diagrams and double number lines. And what I really like is that no 7th grader comes in really understanding how a tape diagram or a double number line works. So they're all brand new learners in learning those visual representations. So we practice a lot of connecting the representations, and this is a sample of part of my percents unit where we had a word representation, there was a double number line, there were proportions, decimal equivalents, and you might notice there's not even a question to answer. So it really starts to bring out the conversation with students about, okay, well, great, so you found what the tip was at 20%, so what could we do if we wanted to find, the total amount they paid? And it just brings up different connections between the quantities. And since I began to explicitly teach the tape diagrams and double number line before bringing in equivalent fractions and proportions, students are actually choosing to use them to solve complicated percent problems instead of the more traditional proportion way. And so recommendation 4, being able to expose students to multiple problem-solving strategies, we're providing more avenues for success for some of our most struggling learners, in addition to being able to teach them how to use those visual representations.
So I have a question, Becca, before we transition to another slide. You just mentioned recommendation 4, exposing students to multiple problem-solving strategies. Can you give another example of that, as well as how you have integrated recommendation 5, helping students recognize and articulate mathematical concepts and notation?
Sure. So we mainly in my ratio and proportions unit. So we would start with our tape diagrams and our double number lines, and then we start to bridge it into some expressions and equations. And so talking about how proportional relationships are related to linear relationships and bringing in a graph as another connection for a problem-solving strategy. And it's just really important for that recommendation 5, just to make sure that we're teaching them the right notations for things, so that way when they're labeling their visual representations, the correct mathematical idea is coming across.
There is another point, if we look at recommendation 5, that talks about having students explain the steps of their problem through a worked example. Have you used those strategies as well in your classroom?
Yes. So there's a few different apps, and especially with remote learning now, I'm discovering more and more every day, it feels like. But the Flipgrid app I actually used before remote learning had started, and kids are able to talk through the steps that they use to solve the problem. And besides doing those Flipgrids, kids are turning and talking, and they're working in small groups, and it's really about creating a culture of discourse in the classroom, so that no matter whether a kid thinks they're right or wrong, they're sharing out how they did something so that they can make connections to what other students have done in their strategies.
That's excellent. You also highlighted aspects of recommendation 2, which is assisting students in monitoring and reflecting on their problem-solving process. So those are great examples. So what I'm going to do is just talk a little bit more about other resources, and then start to take some questions from participants as well. So one of the things that happened in light of the COVID pandemic is that a number of families, parents, community support folks have stepped in and helped to support learners in their education. And one of the resources that was developed in this time is an actual family and caregiver activity guide that goes along with the problem-solving practice guide. And in that, if you follow the link, you'll find that there are sample tasks similar to the ones we put in the slides here, but also guidance about how a parent would support their student, their son or daughter in this process. So it's a great resource to have out there in the field. So I'm going to now look for questions in the chat. And I will be seeing if we can find some. In the meantime, as these are being written in, One of the questions that was posed by someone upon registration was somewhat answered, Becca, by you, but I'll just ask this to see if you can give a little more detail. The participant said, as a math coach, how can you better help the teachers to plan better mathematics lessons? Do you have thoughts on that?
Yeah, I think that through professional development, a lot of times it's geared towards the group as a whole, and I think we need to be more intentional about how we're providing our PD to teachers and providing the time that's necessary to be able to really dive into the different strategies we want to use with students. And most of the time when I'm given a PD where it's like, okay, so explore this resource and talk with your grade level counterparts, those are the most helpful times for me. My team works very well together, so I recognize that that is for sure a big part of it. Having a really great culture of teachers around you is very helpful, but having the time to talk to them and, okay, so we're teaching tape diagrams or we're teaching double number lines. How are we going to do this? What are the assignments going to look like? What is the assessment going to look like for these students? And teaching is just notorious for feeling like you have no time to do that. And so to the extent that they're able to, department heads, coaches, admin, whoever it might be that's planning it, if you can provide the time for teachers to really struggle with these problems and figure out how to implement them, I find that to be the most helpful.
Thank you. That's very helpful. Another question that was posed upon registration was, can you apply this work to distance learning and English learner students? I believe Becca gave a couple of examples of how she applies recommendations, some of these recommendations to English learners and also in the context of online learning in this time of COVID. A couple of things I want to point out. While this practice guide doesn't explicitly target English learners in terms of the evidence base that Herb talked about earlier, there are additional practice guides. There is one, Teaching Academic Content and Literacy of English to English Learners in Elementary and Middle School, that talks about some of these strategies specifically for English learners. And there's a practice guide specific to assisting students struggling with mathematics in response to intervention for elementary and middle schools. And some of the recommendations there actually align directly with recommendation 3, teaching students to use visual representation. So in that particular case, that intervention materials should include opportunities for students to work with visual representations of mathematical ideas, and interventionists should be proficient in using visual representations for mathematical ideas. So there is evidence, and you'll find that in this as well as additional practice guides. Part of that question also asked about distance learning, and I'm going to turn it over to Herb to answer that question and give a little more detail. Thanks, Herb.
Oh, thanks, Pam. So I just wanted to, I was just going to add on to what you had said in terms of there is on the What Works Clearinghouse homepage, there is a studies of distance learning where the Clearinghouse did a rapid assessment of the effect of distance learning interventions on student outcomes. Now, it's not limited to mathematics, but it includes mathematics.
Excellent. That's really helpful, Herb. There's a question here that was posed about differentiation at middle school level is hard. Please share specific instructional connections between practice guides and differentiation. Differentiation, yes. So Becca, I know that you have done some things in your classroom you might highlight, and then Herb, if you have other thoughts, you could add those as well.
Sure, and as a 7th grade teacher, I have students coming in that really should be in algebra in the 7th grade, and then some students who come in that are still struggling with addition and subtraction. So I totally understand that differentiation at the middle school level is being hard. One of the key points, though, is with visual representations, I think you'd be hard-pressed to find a 7th grader who could come in and be an expert on how a double number line can be applied to a proportion or percent problem. And so students coming in usually don't have the experience with the visual representations, and so that can be a great starting point to have every student on the same page learning explicitly how to use these visual representations. And then it also provides an opportunity for extension for those higher level learners to say, wow, great job solving it with the double number line. Can you show me how it would look on a tape diagram? Or can you show me how this would look if we set up a proportion? Where do you see the connections between these two representations? And I think as all learners, every time we dive deeper into a representation or a diagram or a problem, we see different connections that we might not have seen the first time. So in addition to having all the kids learning this really for the first time, you're also helping the other students to make more connections to the conceptual material that maybe they already came in knowing a lot of it, but being able to make those extra connections really solidifies their learning.
That's really excellent. There's another question here in the chat about have these techniques been successful with English learner students, and how? One of the things I just want to highlight is in the intervention that we produced and ran that Becca was also a part of, we included teachers integrating these strategies and collecting student work and analyzing that student work of all students, and they had focused students specific to English learners, and there were a number of examples where there was huge success for students. And Becca, do you have an example or two from your own work to respond to that question?
Yeah, so that year actually I was participating in VAM. The student that I had as my, I guess, case study student, the one who I would bring the work and analyze at the course meetings, he was from Egypt and spoke very little English, and teaching in Framingham, most of the students speak either Spanish or Portuguese. So usually I can get by with another kid in the class helping out if the student doesn't know very much English. But in this case, it was Arabic, and so I had no assistant, I guess, as you might call it. But being able to sit with him and draw out a tape diagram and underlining like what the whole was in the situation and helping relate that to the whole rectangle and then splitting into parts was really it was a really enlightening experience, because we know that these students are coming to us with a lot of knowledge, but the problem is transferring it through the language barrier. And so visual representations give us that opportunity to make some connections across language, looking at how big something is or a quantity and how we split it up. And it really provides an entrance point for our ELs.
Excellent. Let's see if there are any other questions in the chat itself. I don't see more, so I'm going to tap into another question. And Herb, I think that you're going to take this. How can these strategies be used to transfer to high school age students? How can the strategies be used by special education students? I think you had some thoughts about that, and as it relates to other practice guides, perhaps.
Yes, and that's a great question, Pam. And I think, first of all, in terms of how can these strategies be used to transfer into high school age students, I think it's important to just remember that the mathematical problem-solving practice guide, the evidence, which gives us confidence that the recommendations can improve the outcomes for students, was based on studies of students in grades 4 through 8. Now, that does not mean you cannot apply these strategies to your high school students, but what it does mean is that we don't have as much confidence in terms of the evidence that these recommendations would work with high school students. And so you want to pay particular attention to these practice guides and the groups of students for which the levels of evidence is based. And then in terms of the question of how can the strategies be used by special education teachers, I think that's something maybe Becca may want to speak to more in terms of the actual strategies. But in terms of the application of the evidence, the practice guide, it basically starts off by saying that the guide is intended for use by all teachers, including those in general education, special education, teachers of English learners, of mathematics in grades 4 through 8. So if you're a special education teacher and you teach students in grades 4 through 8, the idea is the confidence we have in these strategies in terms of the evidence would apply.
Excellent. And I just want to reinforce also that the Assisting Students Struggling with Mathematics RTI guide from elementary and middle schools also includes some of the same or similar recommendations, and so that could be referenced as well, and to see specifically for those students who are struggling or have been identified as needing our response to intervention services. So
that's a great point.
Yep.
And
So
Pam, if you
Sure,
don't mind, I can jump in too.
Sure.
I've used these strategies in my inclusion classrooms, and I don't just have 1 or 2 kids with IEPs. I have almost half the class for my inclusion and then a handful of ELs as well. So these are strategies that work with any population of students. This is not just something that I did in my class full of nons. This is every class, my struggling classes. And in my struggling classes, it's actually more successful than in my class of kids without any, extra needs, any IEPs or ELs or, those types of situations. It gets them talking and it gives them confidence, and they're all of a sudden excited to be there because they understand.
That's excellent. What a great example. I'm looking at the question, the chat, and I would recommend anybody who has additional questions that we haven't yet answered to please add those to the chat at this point. Before I wrap up here, I want to make sure that if there are any additional points that either you, Herb, want to make, or Becca, that we do that, and then we can transition. So, Herb, do you have any additional thoughts before we transition to the end of this webinar?
Yes, I do, and it has to do with Pam, an additional question we had that came in prior to this webinar, and that question was: is the guide a process that is adapted to different skills, or is it a book to follow? And I think the examples that you have walked us through and Becca have walked us through, I think illustrates one of the main points of the practice guides, and that is it's not a cookbook to be followed, but a series of strategies that are to be adapted given your classroom conditions, given your students.
Excellent, thanks, Herb. Becca, what about you in terms of any of these recommendations or other things you have learned when you've implemented these in your own classroom?
I guess the only other thing to say is that it's hard. This isn't like you get the recommendations and now everything makes sense and everything is easy. It takes time and it takes work, but it is absolutely worth it. When kids are able to show you how they're thinking or talk through how they're thinking and show you how they can solve things in different ways, it just gets them so much more engaged, and they take much more ownership over their own learning when they're able to be able to participate in class in these ways.
Excellent. Thank you so much, because I know certainly you've had a busy day being online with your own students. So to join us here for this is just wonderful. Thanks, Becca. There was a question in there's a question, another question that was in the question submitted upon registration, and that was, what other guides are there, what other resources are there that are freely available? And so I just want to point out other practice guides specific for mathematics educators. So the question about transferring some of these ideas to high school, there is in fact teaching strategies for improving algebra knowledge in middle and high school students. You'll find some of these recommendations are similar, and there's a strong research base for those recommendations, as Herb pointed out. Teaching math to young children, again, very similar. All of these practice guides have the similar format and provide not only the recommendations, examples, but also how to overcome roadblocks to implementation, because as Becca noted, it's not really easy, but it's really worth it, and these are recommendations based on lots of research. The RTI guide I mentioned earlier, there's a practice guide on encouraging girls in math and science, using student achievement data to support instructional decision making, gets to the question that someone posed about planning. There's also another practice guide that hopefully is soon to be released, and I'm not sure the exact release date, but an updated version of the practice guide to support struggling math learners, and that extends the grade level, I believe, there. So lots of good resources for you to use. So I wanted to make sure to say that we really appreciated your engagement and the questions that were submitted prior to the webinar itself. Make sure that you please fill out our survey, because it helps us to refine and make these events better, and make sure that they're targeted to your questions and needs. If you have additional questions, here are our email addresses. We are really open to answering those, so feel free to email us. You will be receiving the resources, as well a link to the webinar archives in case a colleague or a friend didn't have a chance to join us today and you want to share those materials. So with that, I'm going to thank our other presenters. Herb, thank you so much. Becca as well, and thank you all for joining us on today's webinar.
Thank you all for joining us today. As Pam mentioned, today's webinar recording will be archived and uploaded to IES's YouTube channel. So if you registered for today's webinar, you'll receive an email from us with a link to that recording as soon as it's available. Have a great rest of your day.
Thank you.